we have seen that in previous cases, we have not considered the priority over here. Only burst time and arrival time was given. But now in the priority scheduling, will be given with a priority that will be assigned with each of the process. What is priority? Priority is an integer value. Correct? That means the smaller the integer, highest is the priority. That means 1 is the highest priority, 2 is the lesser, 3 is the lesser, like that. So smaller the integer, higher is the priority. And the processes will be allocated based on their priority. A process with higher priority will be processed first before any lower priority process. Is it understood? Suppose I have a printer. The printer is in your college. Suppose one printer is which is need to be shared by all the people. Student can take print out, teachers can take print out, the management people can take print out, the dean and directors can take print out from the same printer. Now every people has a priority assigned with them. Correct? Suppose a person, you are a student, goes for taking a printout. In the meantime, another person, may teacher, come over here. He has to take some printout over there. Then the student have to wait because the teacher may have a higher priority. While the moment teacher is taking a priority, suppose principal will come and he has some important work and has more priority, and then he will be given the chance. So based on the priority, the process will be allocated to the CPU, right? So priority scheduling can be preemptive or non-preemptive. That I already said. It is a preemptive or non-preemptive scheduling. And SJ, if you think about the SJF, shortest job first, that we have discussed earlier, this is also a priority scheduling. But how it is we say it is a priority? Because we give emphasis, we give priority to what? We give priority to the CPU burst time. That time there. Shortest job means we are giving priority to what? The shorter jobs means burst time we are giving the priority. So what is the limitation over here? The limitation is the indefinite blocking or starvation. This one you remember. Which of the scheduling algorithm causes starvation? Which of the scheduling algorithm causes starvation? Which one will cause starvation? The priority scheduling. Why it is there? Because the student might be waiting to take a printout, a page of printout, and many the management people, the principal, dean, director, teachers, they will come, they may have more priority, and the student will go into starvation. So the lower priority processes may never execute. So it will just wait like that only. Is it understood what I am saying? Is it understood how it goes to starvation? A lower priority process may be neglected or may not be given a chance even, because every time a higher priority process will come and it will get its chance. So what is the solution for the same? The solution is edging. Remember this term is important. What is edging? Edging is the increasing the priority of the process gradually increasing the priority of the process. Gradually increasing the priority of a process is known as edging. Correct? That means, what does it mean? Suppose you are a student having a priority 4 or 5. Now a teacher came, that means he may have a priority 3. So he will get a chance. The moment the teacher is taking printout, the principal will come and he may have a priority of 2. So he will have better chance. He will have, as he has more priority, he will get the chance. So in the meantime, so every time, so even if the principal has finished execution, the student is still waiting. Even if the teacher has finished execution, the another teacher may come and the student will be in starvation. In that case, what we'll do, we'll gradually increase the priority of the process. That means the student which has been assigned with 5 value, now will increase it to 4. After waiting for some time, we'll give the priority of the teacher, we'll give the priority of the principal, will give the priority. So gradually we will increase the priority so that this process will be selected. Is it understood or in doubt? Any doubt till now you say, so that we will go for a problem. Is that understood? Is it understood or not?
Yes, sir.
Okay, let's go for a problem now. we'll go for a problem. Suppose this is given. You see over here, process burst time, but arrival time is not given. I will tell you that arrival time, the case when arrival time will be given. Here, arrival time is not given, but priority is given. But the priority is given over here, right? So, can you tell me which process will execute first? Anyone who will execute first?
P2.
2. Suppose I will have two processes have the same priority. Two processes have the same priority. Who will execute first?
With less burst time.
No, we will not consider the burst time. Again, we will have FCFS. But here arrival time is not given. So how will you go for FCFS? So you can go for any one of them. You can go for any one of them. Not necessary that you will look into the burst time. Right? So you can now look over here. So P1 will execute. I am first going for the non-preemptive version. I am going for the non-preemptive version, then I will go for the preemptive version. So non-preemptive means once the process is assigned, we will not take it out from the processor. So P1 will execute for how much time? For 1 second. After P2 will execute for 1 second because its priority is 1. After P2, so P2 has finished now, right? So next which process will come? Next which process?
5.
P5. So P5 will execute for 5 and P5 will over, and like that you will have 3, then this will over, then you have 4, then this will over, and 5. So now, so you can see over here, first P2, then P5, then P1, P3, P4. It's very easy or not? Are you getting me what I'm saying? Is it clear or is it understood or not?
Yes, sir.
So P2 is from 0 to 1, P5 from 1 to 6, P1 from 6 to 16, P3 from. So accordingly, you can compute the waiting time. Waiting time is for P1 it is 6, for P2, P5, P2 it is 0. Why it is 0 for P2? P2 got at 0 and P2, look over here, this is P2. Arrival time is not given. So this is only the, we will compute the, assuming that all has came at the same time. And we have computed it to be, this is the average waiting time. Similarly, we can also compute the, which one? The turnaround time. Is that understood or not? This problem is understood. Here arrival time is not given. But in your question, you will get a question where the arrival time will be given. For example, this problem. There are some processes over here, P1, P2, P3, P4, P5, P6, P7. Their priority, arrival time, burst time, everything is given. Right? Now it is being asked to count the, to find the average waiting time and turnaround time. Correct? Can you compute or not? Who can say who will execute first? Who will execute first?
1.
1.
P1.
What is the priority for 1? Priority for 1 is 2.
2.
So this is smallest among all. But even if the priority is 20 over here, even if the priority is 20, but still we will select 1 first. Why it is there? Because this is the first process that is arrived. There is a query over here. If high priority process use up a lot of CPU time, will the lower priority processes starve and be postponed indefinitely in the context of? Yes, if a higher priority process takes a lot of time, even if it doesn't take a lot of time, many processes having higher priority processes are there, then the lower priority process will go into starve. So that may occur. So starvation is a common problem in priority shift. So that will be postponed indefinitely. The lower priority process will be postponed indefinitely. This is true, right? Either a higher priority process has a larger burst time, or there will be very large number of higher priority processes will be there with different burst. Then also the it has to be the lower priority process has to wait, or it is in starvation. Starvation doesn't mean that it will never get a chance, but even if it is ready, it is not getting a chance. Okay, I hope it is. I have answered your query, Vanisri.
Yes, sir. Yes, sir. Thank you.
Suppose the process ID is 1, arrival time is 0. Even if the process ID is 20 for the process ID, still we will select process 1 first, because the arrival time is 0. Because at that time, no other process was there. Therefore, we have to select the process 1 anyway, right? So, see into this Gantt chart. So, we'll select P1, definitely we'll select P1 first, right? After P1 is taking how much time? P1 is 1. Then you will select, look into the priority. We're looking into the priority. We'll see the P, looking into the priority. Oh, sorry. See, the P1 is executing for 1. After 1 second, who has arrived? After, very interesting question, this one. Try to understand. P1 is executing, right? P1 is executing and it over 1 second. Which one will be given the next chance? Can you see that which one will be given the next chance? Next priority is which one? Which is the next smaller priority?
3.
Which one? P1 already we have selected. Which one is the next smaller among next smaller which is available? P3. But why the P3 is not selected?
P3.
Why P3 is not selected over here?
Because arrival time is 2.
Because P3 has not arrived at that time. P1 is executing for 1 second. 1 second P1 is over. After 1 second, do you think any of this, who has arrived? Only P2 has arrived. After 1 second, only P2 was there. None of this process was there. So definitely P2 will be given. So this has to be keep in mind. After 1 second, only except P2, none of the process was there. So we do not know their priority. So only P2 was there. So P2 was given the chance. P2 takes 7 seconds. So when P2 takes 7 seconds, in 7 seconds, all these processes up to P6 has arrived. Are you getting me what I'm saying? P2 is now 7 second burst time. In 7 seconds, P3, P4, P5, P6 has arrived. Now, as these are arrived, among these, which is having the highest priority, we found P3 has highest priority. Then, so P3 will execute. So P3 will execute for what? 3 seconds. That means up to 10. But still, up to 10, only these processes are there. This process 7 has not arrived. Right? So among these two, we'll find P5 is smallest. So it will execute for 5. So 15. 16 it will go to P4. That's P5. Now what will happen? So in the first P5, then P4. P5 is given. So it is now up to 10. So can you see that which one will be given now priority? Among these, the P4 having the lower priority, so it will be given the chance. So in the meantime, all processes has arrived. Now all processes are there. So then we'll look into the priority and assign P2, then P7, then P6. Is it understood, or I'll explain again? Is it understood, or I'll explain it again? Hello?
Yes, sir, one more time.
Okay. So listen it carefully. We have 7 processes, their priority are given. Correct? First, we'll look into the arrival time, then we'll look into the priority. Gross time is third one. First, we'll look into the arrival time. As we do not have any process at time 0, so time 0 only first process was there. So anyway, we are going to, whatever the priority may be, we have assigned the P1 first. P1 has executed for 1 second, so we have given 0 to 1. So P1 has finished its execution. Then we'll see at time 1 which process are there. At time 1 we found only one process is there, that is process 2. So as it is the only process, so we'll be given the chance whatever the priority may be, we'll given. So it has time 7, so we'll given the P. This is 1 second, it's wrong perhaps. P2 is given for 7, this is 7 actually. P2 1 to 8. This has to be 1 to 8. This is wrong, written wrongly over here. This so P2 will be given chance and a Bross type of 7. So this becomes 8 over here. P2 is from 1 to 7. You have to correct it. Actually, I have made mistake over here while writing. We change it here itself. Otherwise, you will get. I think this slide I have already given you. So whatever I am changes I am doing to make necessary changes over there as well, because I have already circulated. So Bross time of P2 is 7. Therefore, P2 is 1 to 8, not 2. This has to be 8. This has to be 8. So this is not 2. So P2 is up to 8. Now, in time 8, who has arrived? In time 8, P3, P4, P5, P6, these are arrived. These are arrived in the time of, in between time 8. Among these, which is having the highest priority? Which having the highest priority? So this is finished. 1 is finished, 2 is finished. Which is having the highest priority?
P3.
P3.
P5.
P5. P5 is 4. P3 is 3.
Sorry, sorry.
So P3 is given. So now P3 is given. P3 time is what? 3. So 3 means 8 plus 3. So this will go up to 11. It will go up to 11. Is that understood? In 11, which processes are there? At time 11, which processes are there? P4, P5, P6. P4, P5, P6. Among these, which is having the smallest? Which is having the smallest?
P5.
P5. So we give P5 and 5 seconds, so we make it 16. 5 seconds, so we make it 16. Is that understood? At time 16, which processes are there? At time 16, which processes are there? This process is there.
P6, P7.
P4, P6 and P7. Among these three, which will get the chance?
4.
P4.
Very good. P4 will get the chance because it has the smallest priority. Now it is 6, so it will be 16 to 22. This is from 16 to 22. Correct? So this has finished. We are left with only 6 and 7. With 6 and 7, this has the lowest. 7 has the lower priority. 7 will be given 8 seconds. So 8 is how much? 8 is 30. So 22 to 1, P2, P. This is P7 actually. P7. So P7. So it is 30. Is that clear? Is it understood or anybody having doubt? The 7 is over here. Now left with P6. Now for P6 it is how much? For P6 it is 6. So it is up to 36. This is not there. So up to 36. Is it clear? Is it understood or not?
Yes, sir.
Sir.
So I will make necessary changes over there. So not to worry, I will make necessary changes on the slide, and if possible, I will send it again. I do not know how this so much of error left over there. So accordingly, the average waiting time and turnaround time can be computed. Can you compute the average waiting time and turnaround time from this? Can you compute or not? P1 got at 0, 0 minus.
Yes, sir.
Okay. So this is for preemptive. Preemptive was quite easy because once P1 is given, it will take whole time. Once P2 is given, it will whole time. But we'll go for, sorry, we have gone for non-preemptive. In non-preemptive easy because once the process is given, assigned, it will take the whole time. It is taking the entire time for execution. Now we'll go for preemptive version of the scheduling. Same problem, we'll go for preemptive scheduling, right? So this is another example of non-preemptive. This is another example of non-preemptive. I believe you can do of your own. This priority, arrival time, burst time, we'll look into the time 0, the P1 will be given. This will be executed for 4. Time 4, in the time 4, who has arrived? In time 4, these 2 has arrived. So this has already finished. These 2 has arrived in time 4. So who will be given the chance? P3 will be given the chance, right? So P3 will be executing for 5. So 5 plus 4 is 9. So in 9, we can see all processes has arrived. So now you go on selecting from the priority basis and execute it. And this is the way it is being executed. First P1, then P3. You can see over here. This is P1, then P3, then it goes on. Can you compute or not? Can you do it this of your own? Or I will explain it. This one. Exactly the same way. This is non-preemptive. Hello? Hello? I couldn't hear. Is that understood?
Yes, sir.
Okay. So now we'll go for the preemptive priority scheduling. The preemptive priority scheduling is a scheduling algorithm that is used when a process enters the ready queue first. We compare the priority of the process with the way the preemptive version of the SJF was working. Here exactly same way the preemptive priority will work. In preemptive SJF or SRTF, what you do? SRTN, what you do? Whenever a new process comes, we compare the burst time of the current one with the remaining time of the previous processes. Here we'll do the same thing, but what we'll do, we'll compare the priority of the current one with the priority of the previously executing process. Whichever having the higher priority, you will be given the chance. Let us take this example. Suppose I have these processes. Suppose I have these processes. Correct? Okay. So I have these processes P1, P2, P3, P4, and with this timing, I'll execute in an Excel sheet. It would be better to let this is the process ID. I have arrival time, I have burst time, and the priority. This is given. PID, P1, P2, sorry, P2, P3, and P4. The 4 processes are given with the, and what is that? 11, 22, 33, 44. 11, 22, 33, 44 is given. this is gross time 11, 22, 33, 44. This is the gross time, and sorry, this is the priority. This is the priority, and arrival time is 0124. Arrival time is 0124, and gross time is given as 5421. 5421. 5421. Okay, so the C over here, I am going to have so this is my, so can you tell me which one will execute first? Which process will execute? Okay, let just. So arrival time, first we'll look into the arrival, then we'll look into the priority. Arrival time is 0, so P1 will definitely execute. So P1 will execute, but P1 will execute for how much time? P1 will execute for at least for one time, because the P2 has arrived, correct? So till the time the P1, look over here, P1 has arrived. When the P2 has arrived, P1 has executed for 1 second. Can we get, when P2 has arrived, P1 has already executed 1 second, so 4 seconds left. Now P2 has arrived. Now what is the priority of P2? 22. What is the priority of P1? It is 11. So these two are being compared. We found P1 is lesser. We found P1 is lesser, so P1 will continue its execution. Right? P1 will continue its execution. Sorry. P1 will continue its execution. Correct? Are you getting me? Now, after 1 second, again after 1 second, that means now this 4 minus 1, it becomes 3. So after 1 second, P3 has arrived and its time is 33. So 33 priority is compared with 11. So still P1 is less, so it will continue. Then after 2 seconds, the P4 has arrived. It has 44 and still the priority is 1. So P1 will continue for the entire time. Here in this example, the priority, this example what is given over here, the priority is the higher the value, higher the priority is given over here. Here in this example, higher the number, higher the priority is given. That means 22 is having higher priority. But the way I have explained is assuming that 11 as the lower number is the lower priority. It usually happens the lower number is lower priority. Anyway, so P1 will execute first, definitely, then P2, then P3 and P4. If it will be suppose higher number, higher priority, can you tell me how what will happen? Suppose higher number is the higher priority, that means 44 is having higher priority, 33 is having higher priority than 22 in this way. So P1 will definitely execute first, but just after 1 second, P2 has arrived. So P1 has executed for what? 5 minus 1, 4. Is it understood? So this has executed from 0 to 1. Now this 22 is compared with 11. 22 is the higher priority. Therefore, P2 will be executed over here. And this is 4 minus 1. That is 3. And then the P3 has arrived. The moment P3 has arrived, it has 33. P2 is 22. P3 has having the higher priority. P3 will be given the chance. So P2 has executed from 1 to 2. It has executed 1 to 2. It has executed. But now P3 has arrived. The moment P3 has arrived, so it will start executing for at least for 2 seconds because the next one comes after 2 seconds. So P3 has executed from 2 to 4. It has executed from 2 to 4. So this has executed for 2 seconds. So 2 minus 2. It has executed. So P3 has finished its execution. Correct? So in the meantime, P4 has arrived. Now we have P1, P2, P4. Which one will execute first? The P4 will execute now. The P4 will execute for how much time? For 1. So from 4 to 5 it will execute. From 4 to 5 it will execute. So 4 has finished execution. So I have 1 minus 1. So we have, this is finished execution. So among these two, which is having the higher priority? P2. So we'll give it to P2. So P2 remaining is 3. So it is from 5 to 8. This is from 5 to 8. And remaining the time is for P1. P1 is for 8 to how much? 8 to 12.
12.
Yes. And accordingly we can compute the what? This is the Gantt chart, and we can accordingly compute the waiting time and turnaround time, everything, the response time, everything you can compute. Is it understood? Is it understood or not?
Yes, sir.
Can you solve a problem if it is given?
Yes, sir.
Non-preempt. So this is another example of preemptive scheduling. This is another example of preemptive scheduling. This you will, I think previous one is which one? So this is given. One example is given for non-preemptive. This one also you can do it using preemptive. How much it will take? So what is the advantages of priority scheduling? The advantages of priority scheduling is simple to understand, user friendly, based on the priority processes are executed, and priority scheduling are chosen on the basis of requirements, memory requirements, user preferences. On this the priority scheduling is being. So these are the advantages. The problem with the priority scheduling is what? Main problem is it may have starvation. It may suffer from starvation. So when multiple processes have the same priority, then I have to apply another scheduling algorithm, maybe FCFS or something, right? The priority scheduling, if the system is crashed, then all low priority processes that are not yet completed will also get lost. So in some, because there are many higher priority processes are running with longer burst time, if it is crashed, the system is crashed, many of the shorter processes with lower priority may be waiting over there, and they are just lost. These are the disadvantages of priority. Main disadvantages is the starvation. Main disadvantage is the starvation. I hope it is understood. We'll go for another important algorithm is the round robin algorithm. Round robin algorithm means, suppose I have 5 processes, a time quantum will be given to the process. Suppose I give 5 seconds. So my control will go to P1 for 5 seconds, then it goes to P2 for 5 seconds, P3 for 5 seconds, P4 for 5 seconds, P5 for 5 seconds, and again it return back to P1. Correct? It is a round robin fashion. If any process having the burst time lesser than the time slot, suppose 3 seconds, I have taken time slot as 5, but the process needs only 3 seconds. It voluntarily releases the CPU. So after 3 seconds, it will voluntarily release the CPU. Is it understood? So again, if you have a tie, then we go for what? We will go for first come first serve. So round robin shielding, each process is assigned a fixed unit time. Time quantum is some milliseconds, maybe some seconds will be given, and it is easy to implement because, and it is a starvation free. It is a starvation free because every process is getting a chance. Every process is getting a chance. Now, can anybody say whether it is a preemptive or non-preemptive scheduling? Whether it is a preemptive scheduling or non-preemptive? Anyone who can say? Whether it is a preemptive scheduling?
Preemptive.
It is a preemptive.
Preemptive.
Yes, yes. Okay. So, okay. So one of the most commonly used technique. So many of the operating systems, even Linux operating system, in Windows, a particular version of operating system, they all uses round robin scheduling along with some other scheduling also. So round robin scheduling is very much popular. If there are n processes in the ready queue and time quantum is q, then each process gets 1 by n of the CPU time chunk, and if no process waits more than this time, it has to be taken. So it is particularly designed for time sharing system. Time sharing means every process will get a fixed time slot. Here it says RR round robin is FCFS with preemption. That means in FCFS we do not have any preemptive, but if you include the preemption, it becomes round robin. Advantages is that it can be actually implemented in system because it is not depending on the burst time, so it is practically implementable. It doesn't suffer from starvation. All jobs get fair allocation of the CPU. All jobs get fair allocation of the CPU. CPU is attending everyone. What is the problem? Problem is the higher the quantum, the higher is the response time in the system. If time quantum will be more, then some process have higher response time. Right, the lower time quantum, the higher the context switching. So only problem is that a lot of context switching will occur because it has to go through different processes. It has to go through different processes. So main disadvantages is the context switching. The main disadvantages is what? The context switching, right? That you have to remember. Let's take an example over here. These are the processes arrival time and burst time. This is arrival time and burst time, and time quantum is given over here as 4 units. 4 units is the time given over here. Now, at arrival time 0, only process 1 is there. So process 1 is given for 4 units first, 0 to 4. Can you see over here? P1 is given from 0 to 4. So what is the time left for P1? If 4 seconds is subtracted, we have 1 second left over here. 1 unit left over here. So in burst time 4, these 3 has arrived. This 3 has arrived. So try to see over here. We were executing P1, but in the meantime, P2, P3, and P4 has arrived. Is it understood what I am saying? P3, P2, P3, P4 has arrived. Yes. Okay. Now, whether P1 has finished execution or not finished? P1 has not finished execution. If it has not finished execution, add it at the end of the queue. Add it at the end of the queue. Correct? Now so this is a queue kind of thing. So it is add at the end of the queue. Now who will execute? Look into this queue and say which one will execute now? The P2 will execute. We'll go from this to this. We'll go in this direction. So now P2 will execute. So we are having P2 over here. P2 will execute for how much time? 4 seconds, because our unit is 4 for everyone. So P2 will take 4. So we'll subtract 4 over here. So what is the remaining time? 2. So 2 means it has not finished yet. So now it is time what? Time is 8. In time 8, who else has arrived? Now this 2 has arrived. This 2 has arrived. So that means P5 has arrived. P5 and P6, these two processes has arrived. So we'll add it into the key. The order in which they are coming, the same order we will add it. P5 first, then P6. So we have added it over here. Now, is the P2 finished? The P2 has not finished. So therefore, we'll add it over here again. I said if it is not finished, you add it. Correct? Now all processes are added, but we'll look into this queue. So which one will take? We'll take P3. So P3 will be for 4 seconds. But P3 is requiring only 3 seconds. P3 is not even requiring 4 seconds. So 3 seconds is subtracted over here. So this is finished. So this is finished. 3 minus 3 is 0. So P3 has finished. So no need to add it at the end of the queue. So next one, which one will be selected? P4. So we have taken P4 over here. P4 again for 4 seconds, but it is not requiring. It is only requiring 1 second. So this is 0, and from 11 to 12. So no need to add it again because it has finished. Then which one? Then again P1 has to be there. It is given P5. Then the P1 has to be there. As government has some problem over here. Then the P1 will execute. P1 is again given for 4 second time, but it is 1 second is required. So 1 minus 1 is 0. 1 minus 1 is 0. So here you have P1 will execute for 12 to 13. This will execute from 12 to 13. This will execute from 12 to 13. Then it will come for P5. For P5, it will execute for how much? P5 is how much? 5. So you have subtract 4 from here. So we have 1. So P5 is from 13 to 17. P5 from 13 to 17. Then we have P6. P6 is how much? P6 is 4. So 17 to 21. Then it is P2. The P2. So P6 has not finished. So where somewhere it's not finished over there. P5 has not finished. So P5 has to be added. P5 has to be added. If it is not finished, you add it over here. So it P6 is now finished. P6 is finished. The next one is P2. P2 is for 2 seconds. So P2 is finished now. So P2 is finished now, and we left with P5, and P5 is rest 1 time is given. So there is a slight change over here. P1 and P5 to make the necessary changes. Is it understood what I'm saying? So in round robin, we need 2 things over here. One is the Gantt chart, another is a queue required over here. We got a queue over here. So today we have already time, but I will do one thing. You go through these problems again. In the next class, we'll solve some more problems on this. We'll solve some more problems on this round robin, and so that you will have better practice on this. But before coming to the class, go through these slides again, solve this, because I found some of the errors over here, so that I will correct it, and then I will go for again writing over here. Also, I will circulate among you again.
Sir, what is the course for module 2
Module 2 is actually for
and midterm?
up to round robin algorithm. Actually, with a round robin algorithm, most part of your 95, 97, 98% of your module 2 is over. So you can read up to today's class, up to round robin algorithm. Whatever is discussed up to round robin. So these are there. Round robin scheduling will be there. This will not be there for the multi-level. Will be not come in your exam. Rest multi-level will not come up to the round robin. So we'll solve some more problems in the round robin if possible. Some problems are also being solved. Try to solve of your own again. So let me take the attendance. Roll number 2 is permanent absent. 3, 4, 5, 6, 7, 8, 9, 10, 11. 22 is permanent absent. 24, 25, 27, 30, 37, 39, 51, 52, 61, 73. So I repeat the absent roll numbers. Roll number 3, 22, 24, 25, 27, 30, 37, 39, 51, 52, 61, 73. So the next class you come up, you will read those and come with the doubts if you have any. Right? So I'll end the meeting now.